Welcome to this presentation on finding the prefix common array of two arrays. Let's dive into the details. The objective of this problem is to find the prefix common array denoted by C for two given arrays A and B. For each index, Ci represents the count of numbers common in both arrays up to that point. Here's an example. Given A as 1, 3, 2, 4 and B as 3, 1, 2, 4, the resulting array C is 0, 2, 3, 4. We will break down this example further in the next slide. Let's walk through the example step by step. At index 0, no common elements are present, so C0 is 0. At index 1, the common elements are 1 and 3, so C1 is 2. At index 2, we add 2 to the common elements, making it 1, 2 and 3. Hence C2 is 3. Finally, at index 3, all elements 1, 2, 3 and 4 are common. So C3 is 4. This gives us the final output 0, 2, 3, 4. Our first approach leverages bit sets to track sim elements in both arrays. At every step, the number of common elements is calculated by tracking the end of the bit sets and counting the set bits. This approach is efficient with a time complexity of big O of n and space complexity for the bit sets. The code snippet for this solution is shown here. The second approach uses frequency counters to track how often elements appear. Each element is counted when it is first seen, and the common count increases when it is seen in both arrays. This method is simple, intuitive, and maintains an big of n time complexity. Although it requires additional space for the frequency array, here's the implementation. Let's compare the two approaches. Both achieve a time complexity of big of n, but their space complexities differ. While the bitset approach is space efficient, using constant space, the frequency counter requires big of n space for the frequency array. Additionally, the bitset approach may seem moderately complex, while the counter-based solution is easier to implement. In summary, we explored the problem of finding the prefix common array for two input arrays. We examined two efficient approaches, the first using bit sets and the second using frequency counters. Both approaches have their strengths and their choice depends on the problem context. Both methods achieve optimal time complexity, demonstrating the power of algorithmic problem solving. Thank you for your attention. If you have any questions or feedback, feel free to share. I look forward to hearing your thoughts.